Welcome. Today we're going to talk about functions versus relations. Now, a relation is just a relationship between sets of information in math. We talk about it how it's two quantities that are related to each other by some rule or correspondence. And they correspond with one another. I'm going to give you an easy example to kind of understand this concept. Think back to those old cell phones. Maybe your parents had them. Maybe you had one as a little kid, a little flip phone, where all you had to be able to text was numbers. So, for example, if you press the button 2 here, you would get out either A, B, or C when you tried to text. You had to press these keys in order to get different letters to pop up. Okay, this is a relation. That number 2 has a relation with A, B, and C. The number 7 has a relation with P, Q, R, and S. Okay? Relation, just a set of information, two quantities that are related to each other through some correspondence. We can diagram these relations, with a mapping diagram. For example, if you press the button number 2, you get out either A, B, or C. Okay? Domain and range are going to be these words you're going to hear throughout this unit. Okay? Domain is your input values. Okay? If you input number 2, you would get out A, B, or C. Okay? So that is our domain. It's called our input values. Also can be referred to as our x values in our ordered pair. Okay? If we start talking about range, that's our y values or output values. So when you input number 2, you get out A, B, or C. So X input domain, Y output range. So X input domain, those correlate with one another. Y output range, those are interchangeable as well. Relation, pairing of input values with output values. We can be shown as a set of ordered pairs, as a mapping diagram, or a graph, which we'll get into by the end of the video. First example, we'll look at determine the domain and range of the following relation. Well, the domain, again, we talk about it's the x values. So can you pick out the x values in these ordered pairs? Well, we have 89, 92, 98, 103. Okay, our range is all the y values. So the range here would be 32, 34, 36, and 40. Okay. If we pair names and heights, it's a relation. I'm going to talk about how it could be what we call a function. Okay. For example, take a look at the teachers in our school. You got Mr. L, you got PK, you got myself, you got Art Dave. I know I'm definitely taller than PK. But for the sake of argument, we're going to pretend that me and PK are the same height. So we have Mr. L, he's 6'9". PK, 5'8". For the sake of argument, I'm going to say we're the same height, even though I'm definitely taller than PK. And Art Dave is sitting here at 6'5". Each teacher has one output. It's okay that me and PK have the same output. We each only have one output. So this is what's considered a function. When the domain has one and only one output. So each value in the domain has one and only one output. Mr. L has a height, PK has his own height, I have my own height, Art Dave has his own height. This is an example of a function. If we switch our domain and our range, all of a sudden our domain is the height and our range are the people. Let's see if it's a function now. Let's map. So 6'9", that was Mr. L. 5'8", that was Mr. Ryan and PK. 6'5", that was Art Dave. Because 5'8" has two outputs, this is an example that is not a function. Okay, this 5/8 has one output to PK, one output to Mr. Ryan, meaning it has more than one output, therefore not a function. So a function is just a well-behaved relation. It is a special relation such that for all of the values of x, there exists one and only one y value. So each value in the domain has only one value in the range. So if you think back to our first example of pushing that button 2 and getting an output of A, B, or C, do you think this is a function? If you said not a function, you would be correct. This 2 has 1, 2, 3 outputs. So this value in the domain has more than one value in the range, therefore not a function. Let's say we switch it around. Now A, B, and C is in the domain, 2 is in the range. Do you think this relation is a function? If you said yes, it's a function, you would be correct. This A has one output, the B has one output, and C has one output. Each value in the domain has only one output, only one value in the range. It's okay that it's the same. It has only one output. So yes, this would be a function. So that was our mapping diagram. Let's take a look if it's an ordered pair. If it's an ordered pair, we look at x and y values. And we look at, number 1 here, we have 2, 3, 4, 5, 5, 6. Look at the x values, 2, 4, and 5. Those are my domains. They don't repeat. They each have only one output. Therefore, yes, this would be an example of a function. If you look at number 2, do you think it would be a function? Again, 2 has a value of 3, 4 has a value of 3, 5 has a value of 6. It has one and only one value. The x values do not repeat. So yes, it is a function. Take a peek at number 3. Is this a function? If you notice, this 2 has a value of 3, 2 has a value of 5. The 2's repeat. Therefore, no. This last example would be not a function. The last thing we're going to talk about is something called a vertical line test. We can see a graph and determine if it is a function based on a vertical line. So if I drag this vertical line across the graph, does it ever touch the graph more than once? We would say, no, it doesn't. So this first graph is yes, it's a function. We move our vertical line over here. I move it right here. Oh, I see 2 instances. It crosses this graph right here, 1, and right here, 2. Therefore, not a function. Take a look at down here. Would either of these be a function? Check with our circle here. Is it a function? Or using the vertical line test, we could say here and here, not a function. The last one, you bring our vertical line, it passes, so we would say yes, it is a function. So, in a relation, we have ordered pairs, we have a mapping diagram, and we have graphs. To determine ordered pairs or mapping diagram, to figure out if it's a function, we look to find one-to-one. We look to see if there's any x values that repeat to determine if it's a function. Remember, we can only have for each value in the domain, there can only be only one value in the range. For graphs, we use our vertical line test.